Okay, so about naming those angles in 5,000 different ways, basically an infinite number of ways, and that's what's called coterminal angles.
Yeah. So let's just look at kind of an example right here. We've got this angle, and it doesn't really matter what angle that is. Remember, we start at 0 degrees. This
along
would be,
the x-axis, positive direction.
Yeah, that would make this 90, 180, and then 270. And then up right here, if we keep adding 90, we would get
360.
360.
Mm-hmm.
Okay, so right here, this angle that's along the x-axis is 0 degrees, but we could also call it 360 degrees.
Or 720.
Because that's another whole revolution around. Right. And so that's what we're talking about when we talk about coterminal angles, is that we can have different numbers, but them end up being in the same spot. They have the same terminal and initial sides.
Right.
So like this angle right here, which I think I attempted to make be 135.
That's what it looks like to me, to the untrained eye.
We have 135 degrees, but then we could also talk about, well, what if we go all the way around the circle once and then come to this angle?
So you could have 360 plus 135
exactly.
and be in the exact same spot.
So that would be 360, yeah, like you just said, plus 135. And so what we do is we get these questions where they ask us to maybe find a positive angle and a negative angle that are coterminal with whatever they gave us. Well, if I have 100 degrees here, to get the positive one, we'd add 360 degrees.
Which would be 460.
Right, and then to get the negative,
we could just subtract 360. It's all in 360s. That gets you to the exact same point on a circle every time.
Right. So to do this, we added and we subtracted 360 degrees, and that gave us these two numbers. We could keep going, and we could find infinitely many more
angles,
as many as we wanted to, and just keep adding and keep subtracting 360. Yep. How about this 5 pi over 6?
Well, we don't want to necessarily mess with 360 anymore, because now that's a really weird fraction to work with.
Well, and this is in radians.
And it's in radians.
Yeah,
and
so we need to add a radian.
Yeah, we got to put our big boy britches on now, and big girl britches.
So let's talk about maybe what these are like in radians now.
Yeah,
we have
let's do
0
that.
degrees. So
let me just ask you this real quick. What's the circumference of a circle?
2 pi r.
2 pi r. What if our radius is 1?
So that's 2 pi times 1.
Which is?
2 pi.
Which is how far it's going to count on this particular problem as well.
A whole circle is 2 pi.
All the way around one time.
So we're saying 2 pi and 360 are the same, which if you use your conversion, you should find that that's true. Also, we said a while ago that 180 and pi are equal, because that's how we convert anyway. So now that leaves us with, what is 90 degrees in radians?
Be pi over 2.
Right, and the way you can think of that is to go from 0 to pi, this is halfway.
Right.
It's half of pi. Okay, and then this would be
3 pi over 2.
3 halves of the way around the circle. Well, around the circle, that's, never mind. Forget I said that. That's confusing. Okay, so anyway, what do we need to add and subtract to find our angles this time?
This time we're going to add and subtract 2 pi, which is the 360 degree equivalent in radian form.
Right, because you could change this to degrees.
You could.
And add 360, subtract 360, but you have to change your answer back to radians, and that's a lot of work. So if we want to add and subtract 2 pi, let's go ahead and get a common denominator for 2 pi.
Let's make it 6.
Let's put a 6 on the bottom, which means we times the top by 6 as well, giving us 12 pi over 6. That's what we're actually going to add and subtract to 5 pi over 6.
And this is going to be fraction adding like you did in 5th grade or whatever. It's no different, except now you're going to have a pi running around, and that is what looks different. But leave the pi in there. All the answers right now are not decimals. They're all pi's. And so when you're done, if you've got 5 pi's and you add 12 pi's, you have 17 pi's.
And that would be a great day if you had 17 pi's.
Yeah. Apple pie, pumpkin pie.
Yeah.
Pecan
pie.
Chocolate
pie.
Oh man, lemon meringue pie.
Negative 7 pi over 6.
So there you go.
Two angles we're going for. Right there. 17 pi over 6 and negative 7 pi over 6.
Bingo, bango, bongo.
Okay.